Okay, operations on functions. Functions can generally be added, subtracted, divided, and multiplied. So we can treat them almost as if they were numbers. Adding, subtracting, multiplying, and dividing. So if I gave you two functions, f and g, let's find the following. First of all, f plus g I don't think you will think is too kind of out of this world. It's going to be 5x plus x plus 2. I'm going to use parentheses, but do I really need them? No. When we do subtraction, I will. That'll be one of the most common mistakes is when we do subtraction. I'll show you in a second. What is 5x plus x? Okay, so this is 6x plus 2. Okay? So all I did is combine like terms. All right, I want to state the domain of this function. I want to state the domain of the function. What does domain mean?
X.
All the x values for which there is a corresponding y. Okay, all the x values for which there is a corresponding y. I think the easiest way to find the domain, there's lots of ways that we could do it, is to look at the graph. This is a linear function. So is there any x that I can put into this function where I will not get back a y value? No, I can put in a trillion, I can put in 0, I can put in pi, and I will get back some y value. So I think the domain for this one is what? Yeah, negative infinity to positive infinity are all real numbers. Let's look at the graph real quick. Can I take this away just briefly? I'll bring it back, I promise. Okay, let's look at the graph. And if everything went right, it'll pop up. Oh, there it is. Hey, magical. Okay, this is the graph. It's just a line. It's going to go forever in the negative infinity direction, and it'll go forever in the positive infinity direction. Okay, so that domain would be all real numbers. Okay, let me see if I can bring back what we had going on before. So we'll bring this back. Oh my goodness, it worked. Okay, how about f of x minus g of x? Well, that's going to be 5x minus, I'm going to use parentheses, x plus 2. 5x minus x plus 2. I'm subtracting the entire function. And this is where we've got to be really, really careful. I'm subtracting the entire function. So this is actually 5x minus x minus 2. And if we simplify that, that is just 4x minus 2. Take this away very briefly.
We can't stop you.
That's a good point. Let's look at the domain of f of x. So here's 4x minus 2. That is also a line. What is the domain? All real numbers, right? From negative infinity to positive infinity. No matter what I pick for x, there will be a corresponding y value. Okay? Let's go back here. And I guess we better write this down. I don't know what's a good color here. But let's write down that this one was, we'll say all real numbers. That was the domain. And this one was, the domain was also all real numbers. This is a fancy R. It just means all real numbers. F times g just means I'm going to take the entire function f and multiply it by the entire function g. So I'm going to take 5x and multiply it by x plus 2. Exactly. So then I've got to simplify. Okay. So I'm going to distribute the 5x, and I'm going to get 5x squared plus 10x. Let's look at the graph. Oop, it's gone. Oop, it's back. Okay, here's 5x squared plus 10x. It's a quadratic function just like we thought. The domain is also all real numbers. Okay, so any questions on IG? I'm always going to start off, and I'm going to try not to simplify anything at first. I'm just going to write it as 5x divided by 5x plus 2. Okay, so I've divided these functions, and this is a function in and of itself, right? Can I simplify that any further? There's nothing I can do, right, Nisha? Are you Googling that just to make sure? Okay. 5x over x plus 2. Let's look at the graph of this thing and see what the domain is. All right, here's the graph. I'm looking at x values for which it makes sense, or for which there's a corresponding y. it looks like if I look at the x-axis in the negative direction, I'm all good until I get to what?
Like -1.
Not 1. -2, right? There's a vertical asymptote. We'll learn more about these later. But the graph breaks right here at -2. Okay? Right there at -2. It never crosses that dotted line. Okay? Now, once I get past that dotted line, however, I can follow the graph for every x value forever. Okay? So the way that I want you to write the domain for this, two ways. You could either write this, all real numbers, except that x cannot equal -2. That's one way. Or we could also write it in what we call interval notation, where we say, hey, you're all good from -infinity up to -2. Something happens at -2 that's bad. You can't include -2. And then you're all good from -2 to positive infinity. First function 6x times x to...
Oh, that's 2 to 3. I thought that was... What was that?
x raised to the 3 over 4, right? X raised to the 3 over 4 power. Why isn't it writing? Nope, x to the 3/4. So, I'm going to take 1 plus 3 over 4. What is 1 plus 3 over 4? 4 over 4 plus 3 over 4. 7 over 4. Okay, so this is 6 times x raised to the 7 over 4.
Do you have to